For the electron configuration review, we're just going to run through all the answers on here. As far as shapes go, you need to know that an s orbital is a sphere and a p orbital is dumbbells. I'm not really going to ask too much about that on the test, but it does come up in the future a little bit. As far as right here, the appears in number of shapes, that's when you're making an orbital diagram. How many lines are you going to write? So for any s orbital, you're going to write one line. For a p subshell, you're going to write 3. For a d, you're going to write 5. For a f, you're going to write 7. Each one of those lines can hold 2 electrons. So over here we have the how many can each sublevel hold. S can hold 2, P can hold 6, D can hold 10, and F can hold 14. As far as the rules for filling these in, here's basically what you need to know. You don't need to know them by name, but you need to know that you're going to fill the lowest energy levels first. So you always have to fill up 1s before you move to 2s, and 2s before you move to 2p, and so on. Hund's rule just says that when you're writing out an orbital diagram, so putting the arrows on the lines, you want to put one arrow on each available line before you start to pair them up. All you're basically doing is trying to keep the electrons as far apart as possible since they all repel each other. The Pauli exclusion principle is just that when you do put two electrons on a line, one needs to be spinning in one direction, one the other. So we represent that with the up and the down arrow. For number 8, you're just adding up all the exponents, and when you do that, you get 51, which is antimony, Sb. For number 9, you're looking for which one has the outermost electron of 7s1. What you do is you go to row number 7. We always start each row with S. So because it says S1, we're looking for the first element in row 7, which is francium. For the electron configurations, you have the order on the back of your periodic table. It's the 1s, 2s, 2p. It's listed in the top right-hand box on the bottom of your periodic table. Just make sure that you're just filling up the first level before you move on. So 1s, 2, make sure it's full, then you can move on to 2s and so on from there. For the kernel, or the abbreviated or the shorthand, because it's called all three, you're always going to find the element. So in this case we found fluorine, which is element number 9. We went up a row and all the way to the right, which was helium, the last element on the right in the first row. We put that in brackets. All that means is that the electron configuration through helium is the same. We then start, and fluorine is in row 2, so we start at 2s, because we always start at s, and we fill in those electrons to get up to 9. So helium has 2, then we have 2s2, so we're at 4 total, and 2p5. That gives us a total of 9. If you look on here, then for orbital diagram, it's still fluorine. We represent the 1s2 with an up and a down arrow, 2s with an up and a down, and 2p. We would put up, 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 and then pair up, down, down to get the 8th and 9th electrons in there. You can see the kind of the rest of the things that are on here. I'm just going to let it pause for a second and go through here. There are 2 mistakes that when I made this copy I didn't get to. Gold continues on from 3p6 and it fills up all the way until you get to 5d9. So if you were looking at your sheet and comparing it, it does end in 5d9. That's my fault for not getting that. And the other one is down here at number 15 for oxygen. It's missing 1s2, 2s2, and like I've said all along, you have to fill in the first ones before you move on. On the back side, notice for number 17 that the high frequency and low wavelength pictures are the same. That's because if you have a high frequency, you have a low wavelength. They're inversely proportional. Same thing with high wavelength and low frequency. So energy and frequency are directly proportional. Wavelength and frequency are inversely proportional. You want to make sure that on the bottom right-hand box on your periodic table, it's listed out from highest wavelength to lowest wavelength. Make sure you know that highest wavelength means lowest frequency and lowest energy, and lowest wavelength means highest frequency and highest energy. For number 20 through 22, you're just using the equations that are in the bottom right box in your periodic table. C is always a constant, 3 times 10 to the 8th. H is always a constant, 6.63 times 10 to the negative 34th. Make sure that you know the units. Wavelength is always in meters, frequency is always in hertz, and energy is always in joules. And make sure you include those on here. And naturally I did not as I did this, but make sure that you include those. Then go through the different parts of the wave and the electromagnetic spectrum, which is on the back of your periodic table. The big thing here with the dual nature of light is light moves like a wave but acts like a particle, just like an electron. Electron is a particle of matter, but it moves in a wave, so electrons move as waves. When those electrons absorb energy, they go from a ground state up to what's called an excited state. When they release that energy, so that's unstable, they fall back down from an excited state to a ground state, they release light in the form of an atomic emission spectrum, or it's also called a line spectrum. The big thing to know there is the light always comes when an electron falls from a higher energy level to a lower energy level. For number 31 to 35, you're basically just hammering home the same points here. The color of light with most energy is violet. Why? because it has the smallest wavelength, the highest frequency. And the higher frequency you have, the higher energy you have. On the same hand, Roy G. Biv, the opposite of V, which is violet, is R, which would have the lowest frequency, the longest wavelength, and the lowest amount of energy. That kind of takes you through everything that you need to know. Make sure that you know how to use your calculator properly so that you can get the powers of 10 right. If you have any questions on anything like that, make sure you ask me before we take the test tomorrow.